for the first time, you are, and I celebrate you with an online case. Yeah. Mwah. If you're already a subscriber, I love you more. So the title of this video is Converting from Order Base to Base 10. Right? There are 3 examples we are going to be looking at. Without any further ado, let's solve. So the first example says convert 5603 base 8 to base 10. Right? Solution. Now, we want to convert 5603 base 8 to base 10. So what we need to do first of all is to write down the place value in the power of 8, right? Because our base is in base 8. So we need to write down the place value in the power of 8. What do I mean? To do that, what you simply do is first of all just number the digits 0, 1, 2, and what 3. So next you write down the place value in the power of 8, starting with 5 rather. I will say 5 times, this is 3 please, this is 3. I'll say 5 times 8 raised to power 3 plus 6 times 8 raised to power 2 plus 0 times 8 raised to power 1 plus 3 times 8 raised to power 0. Right? Next, I will simplify by saying 5 times 8 raised to power 3 means 8 into 3 places. That'll give us 512 plus 6 times 8 into 2 places will give you 64. Then plus 0 times any number gives 0. Then plus 3 times any number raised to power 0 gives 1. So moving on, 5 times 512 gives 2560 plus 6 times 64 gives 384. Then plus 0, we don't need it. 3 times 1 gives what? 3. And when you sum up all these values together, you have 2947 base 10. So therefore, we have succeeded in converting 5603 base 8 is now equals to what? 2947 base, what? 2947 base 10. And that's our final answer. Next, example 2. Let's check example 2. Example 2 says convert 3b9 base 12 to base 10. So I'll write it. Example 2 says convert 3b9 base 12 to what? Base 10. Now what you should know is that this b is written in hexadecimal form. What does that mean? When you are counting in hexadecimal, or rather when you are counting in hexadecimal or duodecimal, this is how you count: 0, 1, 2, 3, 4. Take note, this 12, this base 12 means duodecimal. Right? Now if you are counting in duodecimal, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you get to 10, you write it as A, right? Then B represents 11. Then C represents what? 12. Now this is how you count in duodecimal. So automatically this B simply means what? If you check it here, B simply takes the number what? 11, right? A takes the number what? 10. Why C takes number what? 12, which is the duodecimal. Right? Now we can solve. You start by saying 3b9 base 12. Like I always do, you number it from 0, 0, 1, and what? 2. Next, you count in the power of 12. Right? In the power of 12. What does that mean? You start by saying 3 times 12 raised to power this 2 here. Right? You are counting power of 12 now. Then plus b times 12 raised to power this 1 here. Well, then plus 9 times 12 raised to power 0. Now moving on, what does that mean? 3 times 12 raised to power 2 means 144 plus, now what does B represent? B represents what? 11. I told you already. So you have 11 times 12 raised to power 1 is the same thing as 12 plus 9 times 12 raised to power 0 is the same thing as 1. So 3 times 144 gives 432. 432 plus 11 times 12 gives 132 plus 9 times 1 gives 9, right? Then when you sum everything together, you have 573 base what? 10. Finally, we have succeeded in converting 3b9 base 12 to a number in base 10, which is 573 base 10. Next, we move to the last example, which says convert B4F point A base 16 to base 10, right? So let me write the question. Example 3 says we should convert B4F point A base 16. Now take note, this base 16 represents what? Hexadecimal, right? Sorry, I didn't spell it well. It's supposed to be hexadecimal, right? Now if you want to count in hexadecimal, it's simply 0 1 2 3 4 5 6 7 8 9 10. Sorry, this, instead of writing 10, you write A. Next, B represents 11, C represents 12, D represents 13, E represents 14, F represents what? 15. So you have counted in hexadecimal, right? Then similarly, what you need is B and what? F, right? So if you check it very well, you see that here B represents 11, while F represents 15, right? Now next, we solve. The question says B4F point A base 16. Now what I can do now is order it 0 1 and 2. Now take notes, this is a decimal point. It's simply, definitely the value of A will be -1, because if you remember your number line 0 is always in the middle. You have -1, right? -2, right? Then here you have 1 2 3, positive, negative, and the neutral, right? So here we have our positives, then here we have the negative. Now the next thing is to write it in the power of the base, right? So the first one, we have B times 16 raised to power 2, right, plus 4 times 16 raised to power 1 plus F times 16 raised to power 0, then plus, don't mind this decimal point, since we have already converted it to a negative here, right? So it won't affect. So plus A times 16 raised to power what? -1. Then what do we need to do? What does B represent? I said it before. B represents 11. So you say 11 in hexadecimal. B represents 11. 11 times 16 gives 256. Then plus 4 times 16 raised to power 1 is 16, plus, what does F represent? F represents 15. So plus 15 times 16 raised to power 0 represents 1. Then plus A, what does A represent? Yeah, A represents 10, right? In hexadecimal, A represents 10. Then plus 10 times 16 raised to power -1. What does 16 raised to power -1 mean? Is an inverse. It's still the same thing as 1 over what? 16. Law of indices, right? So 11 times 256 gives 2816. Yes. Then plus 4 times 16 gives 64. Plus 15 times 1 gives 15. Then plus, here we have 10 over 16, right? Then if you add 2,816 plus 64 plus 15, you have 2,895 plus. Then if you convert 10 over 16 to fraction, you have 0.625. And when you add these two together, you have 2,895.625. So we have succeeded in converting B4 F points A base 16 to base 10. Take notes, here is in base 10 to base 10, which gives 2895.625 base 10. Now we have come to the end of this video, and I believe you should be able to solve any kind of question related to WAEC, NECO, and JAMB that looks like this, or this. Thanks, and see you in my next video. Bye.